Picture a wall of steel longer than the Empire State Building is tall floating. That is not an exaggeration. The largest container ship ever built stretches more than 1,300 feet from bow to stern. Stand it on end, and it would tower over almost every skyscraper on Earth. It can carry over 24,000 containers in a single voyage. It is a genuine engineering triumph. It is also, in the cold language of the shipping industry, a mistake. Here is the strange truth. The world's biggest shipping companies spent a decade learning the hard way. The largest ships ever built were obsolete almost the moment they touched water. And right now, quietly, the giants are shrinking. The forces pulling them back down in size are the exact same forces that made them giants in the first place. Stay with me, because once you see why, you will never look at a cargo ship the same way again. To understand why ships are getting smaller, you first have to understand why they ever got so enormous. For most of human history, if you wanted to cross an ocean, you accepted the ocean's terms. A steamship crossing the Atlantic in the early 1900s took 14 days. That was not slow. That was simply the edge of what was possible. Entire business models were built around that timeline. Ports were sized for it. Supply chains breathed at that rhythm. Nobody fought the clock, because the clock could not be fought. Then turbine engines arrived and compressed everything. The fastest ships pushed that Atlantic crossing down below 4 days. 2 weeks became less than 1. So the industry drew an obvious conclusion. Speed was the thing that mattered. Master speed, and you would rule global trade. For a few decades, that was true. And then, it stopped being true. Ship speeds plateaued at around 28 miles per hour. And they have stayed there, essentially frozen, for over 50 years. Push a hull through water faster than that, and the fuel cost explodes. The ocean simply refuses. Speed had hit a ceiling. So the industry reached for the only lever it had left. Size. If you cannot move cargo faster, you move vastly more of it at once. And the logic here is genuinely beautiful. A bigger ship does not cost proportionally more to run. Think of it like heating a house. A mansion costs more to heat than a studio apartment, sure, but not 20 times more, even if it has 20 times the rooms. The walls share heat. The systems scale. A cargo ship works the same way. Double the size of the hull, and you do not double the crew. You do not double the engine. You barely change the paperwork, but you might double the cargo. The industry measures the cargo in a single unit, the 20-foot equivalent unit, or TEU. One standard shipping container. Every ship, every route, every cost gets compared in TEUs. And once cost per container became the number everyone chased, the race was on. Build bigger. Then, build bigger again. Shipping lines stopped competing only on routes and reliability. They competed on slot capacity. The sheer number of container slots a single ship could offer on one voyage. The operator with the bigger ship could undercut everyone on price and still pull in more total revenue. Every incentive pointed the same direction, and once one company built bigger, every rival had to follow, or watch their cargo sail away on someone else's cheaper ship. And the ports played along. To welcome these growing giants, harbors were dredged deeper. Berths were extended. Towering new cranes were ordered. Authorities committed billions to infrastructure built for ships that did not even exist yet. By 2013, that race produced a monster. A vessel carrying over 18,000 containers, stretching more than 1,180 feet. It was too wide to even fit through the original Panama Canal. Naval architects had solved problems of structure and propulsion that would have seemed impossible a generation earlier. The industry looked at this ship and saw the future. What it had actually built was the peak of an era that was already cracking beneath it. Now let's follow one of these giants on an actual voyage. Because this is where the dream meets the water. A megaship leaves a port in Asia, fully loaded, bound for Europe. On the open ocean, everything works. This is the giant in its element. Smooth water, steady speed, the cost per container looking gorgeous on a spreadsheet. Then it reaches the first wall, the Suez Canal. The Suez is the hinge of global east-west trade. If you cannot pass through it cleanly, you are not really a global ship. You are a regional one, locked into routes where nothing gets in the way. And the biggest hulls barely fit. Once a ship stretches past 1,300 feet long and around 195 feet wide, the margins inside the canal's tightest stretches become genuinely dangerous. The steel itself is under strain. The water beneath is shallow. The ship can transit only under heavy restriction, with a small army of tugboats babysitting every careful mile. The waterway built to connect the world's oceans had quietly become an obstacle. Now the ship reaches port. Here comes the second wall. A megaship sits deep in the water. It needs around 52 feet of clear depth beneath its keel just to float without scraping bottom. That is enough water to swallow a 5-story building before the hull even touches the seabed. Most ports on Earth do not have that. The harbors are simply too shallow. So a port that wants these giants has to dredge its harbor deeper, at staggering expense. It has to build longer berths. It has to carve out turning basins wide enough to spin a hull the length of a small town. And it has to buy the cranes. These are the towering steel giants that reach out across the deck and pluck containers off, row by row. To reach across a megaship's enormous width, a port needs special, oversized cranes. Each one costs over $12 million. And a port does not buy one. It buys a fleet of them. So only a handful of ports worldwide can even receive these ships. And the ports that spend billions to do it discovered a brutal second problem the moment the giants arrived. The ships were not full. And this is the part that breaks the common sense logic completely. Everyone assumes a bigger ship is always cheaper per container. Bigger means more efficient. That feels obviously true. But it is only true when the ship is full. Picture a vessel built to carry 18,000 containers, sailing with only 60% of its slots filled. That fuel, it still burns at nearly the same rate. The hull is just as heavy to push through the water. The crew still gets paid. And the enormous loan used to build the ship still has to be repaid. On schedule, every single month. A half-empty giant carries all the costs of a giant and the cargo of something much smaller. Suddenly, its cost per container is not beating a smaller ship. It is losing to one. And then, it gets worse. If that giant arrives at a port that cannot unload it fast enough, a clock starts running. It is called demurrage. That clock can run at around $50,000 a day. Picture a brand new car's worth of money simply evaporating every 24 hours, while the ship sits motionless and the cargo inside it goes nowhere. There is also a hidden fragility in putting so much cargo on one hull. When a single megaship gets delayed by a storm or stuck in a canal, it is not one shipment that is late. It is 18,000 of them. One vessel in trouble can jam an entire supply chain for weeks. There is a deeper trap here too. A megaship locks an operator into a single route for years. The vessel only earns money on the handful of lanes deep enough and busy enough to feed it. If trade patterns shift, and they always do, that giant cannot simply move to a better market. It is too big for almost everywhere else. The biggest ships ever built had become the easiest ships to lose money on. There was one more catch, and it lived in the rulebook. Before a ship that enormous can sail, it has to prove it can be evacuated in an emergency within a brutally short window of time. It clears that test, but only just, and only under perfect conditions. Calm water. A practiced crew. Everyone knowing exactly where to go. That is a very different thing from a fully loaded giant facing real trouble on a real night. The certification existed to satisfy a regulation. It was never a promise that the scale itself was safe or comfortable. So the industry did something quietly remarkable. It stopped chasing the record. Look at what shipping companies actually order now. The new contracts are not for monsters. They cluster around 14,000 containers, big enough to capture real economies of scale, small enough to behave. And there was a perfect target to aim at. In 2016, the Panama Canal opened a brand new set of larger locks. They set a clear, sensible boundary, around 1,200 feet long, around 160 feet wide. A ship built to those dimensions is the Goldilocks vessel. It can slip through the Panama Canal. It can pass through the Suez without a tugboat escort. It can reach the vast majority of the world's deepwater ports, and it can still carry enough cargo to make the voyage genuinely profitable. For decades, the industry tried to rebuild the world's doorways to fit ever larger ships. Now, it builds the ship to fit the doorway. That is the whole story, hiding in plain sight. The giants did not shrink because engineers ran out of ambition. The engineering still works. The steel still holds. They shrank because the megaship era confused two ideas that were never the same thing. Biggest is not best. Biggest is just biggest. The real winner was never the largest ship. It was the right size ship, the one that fits the canals, fits the ports, and fills its holds on every voyage. A ship that can call at 50 ports beats a ship that can only call at 5, even if that smaller ship carries less. Reach matters more than raw size. Flexibility beats brute force. And there is the matter of risk. Spreading cargo across several mid-sized ships instead of one colossal one means a single breakdown no longer threatens a whole season of trade. Smaller hulls are not just cheaper to fill, they are safer to bet a company on. The forces that built the giants, the relentless hunt for the lowest cost per container, are the exact same forces now pulling them back down to a smarter size. A megaship is a record, and records make for impressive headlines. A right-sized ship is a business. In the end, the industry finally learned the difference between the two. Now here is something that should genuinely keep you up tonight. That 14,000 container ship, fully loaded, weighs around 200,000 tons. It cruises slowly and steadily into a crowded, busy port. And it has no brakes. None. There is no pedal, no disc, nothing that grips. So how does a moving wall of steel that heavy actually stop itself before it flattens the dock? The answer is one of the strangest pieces of physics in the entire engineering world, and it is nothing like what you would guess. That is the story we are telling next. Subscribe and stick with us, because once you see how these giant